A while back, I programmed this animation. I think it's pretty neat, but the thing that really makes it beautiful is its simplicity and the mathematics behind it. Take a look at the code. It's only 10 lines. In fact, most of this is just for formatting and style, or updating variables in animation. The for loop iterates through all values of I, so the line is drawn for all values 0 through 360, and we're left with this line function, which takes in an x and y coordinate for each point. These constants are just for scaling or centering the animation and are not needed. This is much simpler now, and it describes the whole animation, but it still may be a bit vague. Let's take a look at the simplest case, the cardioid, when p equals 2. Cosine and sine essentially just give the x and y coordinates of a circle, so instead of thinking about them as x and y, we can think about them as an angle, theta. Now let's see what happens viewing the lines one at a time. It doesn't reveal much, but now let's try tracing the midpoint. It's a lemicon, close to what we wanted, but not quite. Let's try a different point on the line. If you recall, one point on the line is moving at twice the speed of the other, so let's try tracing a point twice as close to one endpoint. And we have our cardioid. If you increase p, and with it change the ratio between the traced point and the line's endpoints, the number of petals increases with it too. And, because the trace point gets closer and closer to the endpoint, the petals become smaller and smaller. In math, it's fascinating how something seemingly simple can lead to something so complex.